tomorrow's quiz is going to look a lot like this. I've given you a bunch of statements about a function f, and you're going to tell me about f prime. You've got 3 minutes without using your notes to show me what you can do. You're going to go solo. This is not for a grade. This is practice for tomorrow. And then Ile, I have a job for you. Get a job today. Yeah, everyone else already started.
Okay.
The kids at North Central, they're almost done. They're fast. They're way fast. Of course, they're watching this whole time delay. So we haven't started, but. Anybody have corrections over here? No? Corrections over here? Okay. One more minute. It's a total compliment. Okay. And your name's in here too, so if somehow we do the whole thing and I don't hear your name, I'm gonna know you are Maya. Alright, here we go. Time is up. Ile is in control. She has the name selector app. When she calls a name, you need to tell me what goes in one of these 10 boxes. It doesn't matter to me which of the 10 boxes you pick. Ile, go for it.
Steven.
Steven.
For the first box, f prime of x is greater than 0.
F prime of x is greater than 0, like everywhere or someplace special? At x equals c, okay. Alright, it's a Monday morning, I know, rough start. Next,
Luis.
Luis, pick a box. Okay.
When f of x decreases at x equals c,
If f of x is decreasing at x equals c, then
then f prime of x has is less than x is less than 0
is less than 0
at x equals c.
at x equals c. Next,
Andrew.
Andrew.
For the cusp point.
Ooh, if f has a cusp point, can you guys all remind me what the cusp point looks like? It's been a while. Cusp point, right? It looks like that, or maybe it looks like that. It's a sharp point. That's the thing. That's the thing. Andrew, tell me more.
Then f prime of x does not exist at x equals c.
Okay, that f prime of x does not exist at x equals c. All right, I like next. What?
Celeste.
Celeste, pick box.
Horizontal tangent line.
Horizontal tangent line. If you have a horizontal tangent line, can you guys all show me horizontal tangent line? Horizontal tangent line looks like that. Well done. Celeste, what do you know?
F prime of x equals 0 at x equals c.
We know you are equal to 0 and x equals c. Love it. Next.
Aaron.
Aaron,
A relative max at x equals c.
what do you know about a relative max at x equals c?
F prime of x is changing positive and negative at x equals c.
Changes from positive to negative at x equals c. And if I asked you guys to draw in the air for me a relative max, what would that look like? Okay, just about everyone's drawing the same thing, which means you're half right. You got to get the other half as well. Relative max could look like that, but relative max could also look like that. It could be a cusp point, which is why the only thing you can say for sure at a relative max is that your derivative changes from positive to negative at x equals c. Don't start making statements about derivatives equal to 0. No, sir. Don't do it. Next. Honeymoon. I knew you were going to go there. Yep. Relative man, what do you know?
It goes from negative to positive.
I'm sorry, what?
Oh, I mean, F prime of x.
F prime of x
Goes negative to positive.
changes from negative to positive
And x equals c.
at x equals c, and there we're looking at like something like that or something like that. All right, next.
Myra.
Myra.
Saddle point.
Saddle point. What do you know about a saddle point?
F prime of x equals 0, but doesn't change sign.
F prime of x equals 0, but does not change sign. And if I asked you guys to draw a saddle point, what would I see? Saddle point, saddle point. Right, saddle points kind of look like that, except they're like, they gotta flatten out. They gotta flatten out. Okay, there we go. Saddle point. Next.
Carmen.
Carmen.
Vertical asymptote.
Vertical asymptote. If your graph has a vertical asymptote, what do you know about the graph of the derivative?
Then F prime of x has a vertical asymptote at x equals c.
Vertical asymptote at x equals c. I love it. Eileen.
Giselle.
Giselle.
Horizontal asymptote as x approaches infinity.
If you have a horizontal asymptote as x approaches infinity, for example, like a graph that looks like that has a horizontal asymptote, what do you know about the derivative?
F prime approaches 0.
Approaches 0 as x approaches infinity. Eileen.
Vertical tangent line of x equals c. Then f prime of x has a vertical asymptote at x equals c.
Okay, remind me, vertical tangent line, what does it look like? Vertical tangent line, you want to be careful, right? Everyone always confuses vertical tangent line, which just means straight up and down, with like vertical asymptote, and no one really wants to see that on a Monday morning. I hope nobody at North Central was eating breakfast. If your graph has a vertical tangent line, then your graph of derivative has a vertical asymptote at x equals c. Everybody okay? Now the one that didn't make it on here, and it really should have, is if I say f has a critical point.
Oh.
What does that mean? Celeste, what does that mean?
F prime of x equals 0 or does not exist.
It means that f prime of x equals 0 or does not exist. Critical point is just this generic term for derivative equal to 0 or derivative does not exist. If you guys can do this, tomorrow's quiz, easy peasy. We get this under control. Excellent, Eileen. I was wondering if the name selector app was ever going to come up on your name. And obviously I chose well. Good, honest young woman that she is. All right, so let's keep on going. We're going to take a name selector back from you because that's far too much power for a teenager to have. And onward we go. On the AP exam, one of the most common free response questions is this idea of functional analysis. They're going to give you one graph and they're going to ask you questions about a graph that you can't see. And you've got to get these things straight. Rather than going all in on like a really hard free response question right now, because we're just not ready, we're gonna go into this one together. Aaron, can you read the introduction to this problem?
Shown below is the graph of the derivative of a function f of x. The graph of f prime of x has roots at x equals -2, x equals
Good
4,
save.
and x equals 5. Using the graph of f prime of x, determine which statements are true and which statements are false. When determining the truth value of each statement, you must justify your decision. All justifications must be based on the graph of f prime of x.
Okay, so for anybody at home who actually wasn't paying attention and you're like, what the heck is a toot? It's supposed to be the word roots, and Aaron, I'm glad that you knew that that was actually what the word was. We can talk about toots later. I have lots of examples for you. All right, trust me. One of the biggest problems that students run across when they see a problem like this is they don't know which function they're talking about, which is why I keep pushing this whole it word. I don't want to hear it. What graph is this? They haven't labeled it, but they told you what graph this is. Oh, I'd be careful. I'd do this again. This is f prime. This is shown below as the graph of the derivative of a function f of x. So this is f prime. And if you're Suraj Birch from a couple of years ago, he was so worried that he was going to forget which graph this was. He wrote f prime in like 20 different places every single time we took a test. I think that's a little bit overkill. Write it at least once though. This is the graph of f prime. Okay? Other things we know, what do we know? F prime has roots at -2, at x equals 1, and at x equals 5. Great. I can interpret that as f prime of -2 equals 0, f prime of 1 is equal to 0, and f prime of 5 is equal to 0. I want to do these first two together, and then you guys are going to get some practice time. Number 1, true or false? The graph of f is decreasing on the interval 1, 5. This is either true or it's false. I care more about the because. I care as much about the because as anything else. So if you think it's true, you're going to tell me it's true because fill in the blank. If you think it's false, you're going to tell me false because fill in the blank. Why don't you have a quick conversation with somebody near you? Is the graph of f decreasing on the interval 1, 5 true or false? And tell me why. Okay, good. Now I'm finally hearing the because.
Because f prime.
All right, friends, let's pull this together. How many guys are going to go with true? Okay, we seem pretty unanimous on that. David, tell me why. True because?
Because when f prime of x is decreasing, it's negative for me.
Okay,
It's negative.
because f prime of x is negative. Where's it negative?
From interval 1 to 5.
From 1 all the way to 5, right? We're below the axis, so f prime is negative. True because f prime of x is less than 0 on 1, 5, and that implies that f of x is decreasing on the interval 1, 5. One of the rules, one of the things that is so important when you're doing a problem like this, all of your justification, the because, has to come back to the graph that you see. You have to tell me what you know about this graph and how it tells you about the graph that you don't see. Pretty good. All right, number 2, the graph of f double prime will have roots at x equals -2 and x equals 0, but nowhere else. We'll talk in a minute. And then you guys are going to get some time to practice. Graph of f double prime will have roots at -2 and 0, but nowhere else. Okay. How many guys are going to go true on this one? 1, maybe 2. False? Okay, a bunch, but that doesn't add up to 11. How many guys aren't really sure? Be honest. Thank you for the honesty. If this is the graph of f prime, can somebody tell me for sure where f double prime would have a root? What would it take for f double prime to have a root? Stephen?
It must cross the polytonated.
Wait, don't, not yet. No, it. If f double prime has a root, what has to be true about f prime? Lewis, help him out.
F prime has to have a relative max or a relative min.
I disagree. I disagree. That statement's too strong, because you're not thinking about this kind and you're not thinking about this kind. Does any, okay, let's do it this way. Does anybody see a place where f double prime has to have a root?
Wait.
If this is the graph of f prime, where would f double prime have to have a root polynomial? At -2, why?
It's bouncing off.
Okay, you're thinking like pre-calculus polynomial stuff. The graph is bouncing off the x-axis. I agree. David, help him out.
There's a horizontal tension.
There's a what?
Horizontal tension.
That's what I'm looking for. F prime has a horizontal tangent line. F double prime is the slope of the tangent lines to this graph. So is everybody okay that we're going to have to, F double prime has a root because F prime has a horizontal tangent line? Okay, so let's go back and read the statement again. The graph of F double prime has roots at -2 and 0, but nowhere else. This should be
Another one.
false. Myra, why false?
Another horizontal tangent.
Okay, F prime has 3 horizontal tangent lines. One of them over here at -2. One of them over here at 0. And then this third one somewhere. Okay? So I'd say something like F false because F prime has what, 3 horizontal tangent lines? At x equals -2, x equals 0, and somewhere else. Right? It makes me a little sick to my stomach to say at approximately 3.5, but the fact is, there's a third place, which means that F double prime will have 3 roots. That means approximate. We're learning stuff every day. Everybody good? All right. So you guys have the next 6 minutes to finish off the rest of these. I don't want to just see true. I don't want to just see false. I want to see true because, false because. You guys are going to talk. Let's make sure that we include our friends. Yes, that's right. The guy ducking out of view is Andrew. He's in witness protection.
Number 1 is I mean 3.
Remember, true because, false because.
Because F prime is greater than 0
Greater than 0.
only if prime
Because there's a relative.
Right, for x greater than 5, I can see that the graph of f prime is positive. So f must be increasing. Right. Your justifications always come back to the graph that you see. Okay. They're going to ask you constantly, here's a graph you can't see, but what do you know about it? And that's where you're going to get the information from.
At x equals 0, the graph of f prime of x change from positive to
This is
negative.
false. Tell me why false. Because.
I don't know how to
Right, if I look at the graph, f prime is not changing from positive to negative. What is it doing? Let's see. The graph of f will have a relative max at x equals 0. F prime is going from positive to positive.
Because at x
So
equals
yeah.
0, f prime of x is not equal.
How much true? You have answered
We're going to tolerate
Wow.
Because f prime of x is equal, x equals 0, does not.
Because at x equals 0, f prime of x does not equal 0.
But that's actually not it. What would have to happen for f to have a relative max? What does f prime have to do?
Changes from positive.
Is f prime changing from positive to negative?
No.
Right, it's positive and it's still positive, not a max.
More so related to the saddle point.
Almost, but with a saddle point, you'd also have the first equal to 0. So there, the graph of f will have a saddle point.
Oh, because at x equals 0, f prime of x does not change.
What do you call it?
So then no.
No, that's out.
Yes, that.
Oh, no, it's not my number 5. Number 5 is
Yeah, this was just set up point at x equals to x.
number 5 is true because it's changing signs. Ooh, God.
Because it's decreasing.
What? No, Carmen, no.
Because it goes.
No!
Not
Wait,
it.
oh, f.
God, no! No, son, no.
I heard that from across the room. Like, I heard somebody say,
These people over here, it. Ugh.
they said it.
F prime of x.
I heard that from over here.
Thank you. You know whose fault it is? Carmen's. I'm just saying, Steven is weak and impressionable. All right, I am not gonna bother writing all these statements out. I need your help again. We need some victims. Otherwise, Aaron is gonna try to answer all the questions. All right, here we go.
Carmen.
Carmen, number 3. For all values of x with x greater than 5, the graph of f of x is increasing. True or false?
True.
True because?
Because on the interval 5 to infinity, f prime of x is greater than 0.
On the interval that I'm interested in, I can see that the graph of f prime is positive, therefore f has to be increasing. Nice. Number 4?
Giselle.
Giselle? Giselle, the graph of f will have a relative maximum at x equals 0.
False.
False. Tell me why.
Because f prime doesn't go from positive to negative at x equals 0.
Love it. This is a false statement. The graph of f prime has a relative maximum, but for f to have a relative max, f prime would have to change from positive to negative. It doesn't do that. Love it. Next one I like.
Myra.
Myra. Number 5, the graph of f has a relative maximum at x equals 1.
True.
Is true. Tell me why.
F prime of x is changing sign.
But be specific, not just changing signs.
positive to negative.
There you go. At x equals 1, f prime is changing from positive to negative, so f has a relative maximum. Love it. Number 6, the graph of f is differentiable at x equals negative 2.
Celeste.
Celeste
True,
is true. How do you know that the graph of f is differentiable at negative 2?
because f prime of negative 2 equals 0. It exists.
Because f prime of negative 2 is equal to 0. What does it take for a function to be differentiable?
The limit from the left and the limit from the right must be equal to each other.
True, even easier than that. I say differentiable, what I hope you hear in your head is
It exists, f prime of x exists.
the derivative exists. Does the derivative exist at negative 2?
Yes.
Yes, it's equal to 0, which is what you said, but all I really need to hear is f prime of negative 2 exists. All right, number 7, the graph of f has a relative maximum at x equals negative 2. Who's that going to, Ali?
Palamon.
Palamon. The graph of f has a relative minimum at x equals negative 2.
False.
False, because?
F prime of x doesn't change. It stays from it stays positive to positive.
There you go. At x equals negative 2, f prime didn't change from negative to positive. It was positive, then 0, then positive again. There is something special happening on the graph of f at this point. Anybody remember? Stephen remembers? What's so special? Something really special. Stephen, what's happening?
Saddle point.
You have a saddle point. F is a saddle point because
Because it doesn't change from positive to negative or from negative to positive. Wait, f prime of x.
duck face. Okay, one more time.
F prime of x does not change from positive to negative or from negative to positive, meaning there's no relative minimum or maximum, therefore it is a saddle point.
Okay, yep. Well, everything you just said. The two things that you need to have in order to be a saddle point, first of all, the derivative would have to be equal to 0. Is that true?
Yes.
And secondly, the sign of the derivative doesn't change. This is also true. Good. All right. Number 8, the graph of f double prime will be below the x-axis on the interval 1, 5. Andrew, the graph of f double prime is going to be below the x-axis on the interval 1, 5. F double prime on the interval 1, 5. Here's 1, here's 5.
True,
Okay, you're going to go with true.
because f prime of x is decreasing from the interval of 1 to 5.
Okay, hold on. What I heard you just say is that from 1 to 5, the graph of f prime is decreasing. Andrew, ignore all those people around you who like to say the word it. On the interval 1 to 5, is the graph of f prime decreasing? This is f prime. Is this graph decreasing? Right, from 1 until like somewhere, call it like 3.5, the graph is decreasing, but then it starts to increase. So because f prime is decreasing, then increasing f double prime has to go from like negative back up to positive. So we would say
It's false.
False.
I was just gonna look at the fact that we have a the point 7 is changing.
perfect, perfect. Andrew, you okay?
Yeah.
All right. All right, and that's, number 9, the graph of f will be increasing faster at x equals negative 3 than it will be at negative 1. If I look at f prime of negative 3, if I look at f prime of negative 1, f prime of negative 3 is a larger positive number, so I am increasing faster at negative 3 than at negative 1. Everybody okay? Okay, this is how we're going to play the game. All your justifications have to go back to f prime. All right, time to push the thinking one more time, and then you guys actually might have time that you can finish up the homework in class. That never happens. All right, I need you all to grab for me, please, either a ruler or an index card from your container. All right. Right, ruler, not ninja blades, not samurai swords, index cards are good. David, mine is bigger, be careful. All right. No propellers either.
I made a rule about that.
I made a rule, I've got rules about all these things for teenagers. Exactly. All right, so last week we started talking about the graph and we started having conversations about concavity and all sorts of F double prime stuff was coming into play. I want to go over this one more time. It is such an important relationship. So, is this graph concave up or concave down? Both. There is a place where the graph is concave down, there is a place where the graph is concave up, and let's agree that on this part of the graph, what kind of concavity? Concave down. So over here we are concave down. And then at some place there is a change. There is a change to concave up. Now, where this change happens is what we like to call the point of inflection. Not point of infection, point of inflection. The point of inflection, I'm going to say, is right over here. Point of inflection. Our working definition of point of inflection is where your graph changes from concave down to concave up, or concave up to concave down. Everybody okay? All right, for this first part of the activity, what I want to do is focus on the part of the graph that is concave down. And what I'd like for you to do is draw in a bunch of tangent lines to the graph, but only on the part of the graph where the graph is concave down. So draw in some tangent lines using your ruler, using your index card. There's something special that I hope you're going to notice. Just draw a bunch of tangent lines. And if you guys don't figure out the pattern, I may never do this activity again. I failed like 3 years in a row. Yeah, if you guys change the instructions for number 1, I regrettably focused on concave down when I should have focused on concave up. Alright, we've got some nice curves, we've got some nice tangent lines. What I'm interested in here is things that you're noticing about the slopes of the tangent lines. What are we noticing about the slopes? I'll take anything from anybody here. Aaron, what do you notice?
Well, it's changing from positive to negative slope.
So you're saying that the slopes of the tangent lines are changing from positive to 0 to negative? Is that true? Anything else that we're noticing? They're changing from positive to 0 to negative. Anything else? Yeah?
As the tangent line be closer to the critical point,
Yeah?
the slopes decrease in like steepness.
Right, we've got positive slope over here, we still have positive slope over here, we still have positive slope over here, but what's happening to those slopes are becoming less positive, and then you get to this maximum and now the slope is 0, and then what about when you get past that point? Now the slope is negative, and the slope is more negative. One word to describe that pattern. The slopes are really positive, less positive, 0, negative, more negative. One word to describe that. They are
Wait.
increasing or decreasing?
No, decreasing.
Decreasing. The slopes of those tangent lines are decreasing. So slopes of tangent lines are decreasing, and that's because of the concavity. It has to do with the way the curve bends. If the slopes of the tangent lines are decreasing, then you know what that tells you about f prime? F prime of x is decreasing. If I asked you to sketch the graph of f prime, what you get is a decreasing graph that went from being way positive to 0 to negative. So if I asked about f double prime, f of x is concave down, f prime of x is decreasing, f prime prime
Less than 0.
is less than 0. So f double prime is less than 0. And if you think back to the conversation we had last week when I gave you guys like the graph of f double prime, we had like a graph of f and then we had the graph of f double prime. When the graph of f was concave down, your second derivative was negative. Now we get to throw on this other piece that if f is concave down, f prime is decreasing, and f double prime is negative. There's one more thing that I want to add on here, even if we unfortunately don't have notes for this. There's something about the relative position about those tangent lines that's worth noting. Where do they live in relationship to the graph? Yeah, that's a strange question. All the tangent lines are above the graph?
No. Wait.
So if you were to use the tangent line as an estimation tool, your estimates, overestimates or underestimates? Overestimates. Try this process again for the concave up part. Okay, yes, we should expect the flip of everything that we just did. Try it. Draw the tangent line. See what's happening here. Draw on those tangent lines and see what happens. No, happy Monday to you too. Yes, sir.
Right side of it.
Look over here.
Yeah, wouldn't that be, that's an underestimate,
Right.
right?
It has to do with the fact that the lines are below the graph. So that's why they're going to be underestimates.
So do you want to change them or keep them on the right side of it?
Well, no, that's where they would be. If you were going to draw a tangent line that is touching the curve once without passing through it, the only place you can draw them is under the graph. But, go through, draw the tangent lines, make sure you're getting this like physical experience. Okay. Oh, yeah. Okay. Your hair is great. There you go. All right, we've got a bunch of tangent lines. Has everybody seen that the slopes of the tangent lines are increasing this time? If your slopes are increasing, then f double prime must be positive. All your tangent lines are below the graph, and all your estimates are going to be underestimates. Okay, so let's summarize the results. You've got a place over there to summarize the results. All right, so summary. If f is concave up, what do we know about f prime? F is concave up, f prime is increasing, and f double prime? Positive. And then, of course, the flip. If f is concave down, then f prime is decreasing, and f double prime?
Negative.
Has to be negative. Now, to help you remember this, can you guys show me what concave up looks like? Faster, draw them in the air. Concave up should look like that. Concave down Looks like that. With concave up, the second derivative is positive, and some calculus teachers like to have their students do that. Right, you get the smiley face, you get the two positives because the second derivative is positive, second, so you want to have two of these. And so Lewis is getting it now, and so of course for concave down, F double prime is negative. Okay, if you want a little bit more, I like to kind of do this in my diagram and do that in my diagram. Just so like not only am I getting the happy face and the smiley face, but I'm also getting like my tangent lines in there. You know, I think like maybe this is like a piercing of some sort. Right? And this kid, like, they just got the piercing, it's really bad, it's painful. Okay. Concave up, smiley face, concave down, sad face. Don't forget your piercings. Everybody good? All right, so here's what I'm curious about. I'm curious to see how many of you all can find for me the exact coordinates for the point of inflection and like prove it. I want to prove something that would hold up in mathematical court. None of this nonsense that's going to start with like, well, it looks like there's a point of inflection at x equals 0. I want a proof. Good luck.
Or you could just find.
You can put it on the back if you want to. You got plenty of room. Yes, you are.
Because you know you have.
It makes more sense.
So that's like as long as they happen somewhere.
Like, yeah.
How can you know for sure where the point of inflection is?
Because prime equals 1.
When f prime equals 1. Why 1? I'm going to let you dangle for a little bit.
Like, when the vertical tangent
Point of inflection. Where do we think the point of inflection is? At 0, 0. Now I need a proof. Okay. I want a proof. I want a calculus-based proof. How can you prove to me that you have a point of inflection? What's so special about the point of inflection? A point of inflection is where the graph changes its concavity. Right, we go from like concave up to concave down. So if that's happening, what do you know about the first group? Okay, I can go with that. I can go with that. What do you know about the second derivative? Oh! I'll be back. If f has a point of inflection, you have a change in concavity.
I guess it's fine.
Which means f prime changes from increasing to decreasing or decreasing to increasing. That means that f double prime
Oh, did you?
is changing sign. Go ahead. Yeah.
So basically it'll just be when f prime changes from positive to negative.
Right. So prove to me, right, where f double prime changes from positive to negative or negative to positive, prove to me that that happens at 0. Number like this. Okay, so where do we believe this point of inflection is at the origin? Okay, right. You can see it from the graph. You can also read it from the paragraph. But I'm really curious about how you could prove it using your calculus knowledge. That's me?
Yes,
Oh, thank you. That was like a snack.
sorry.
Oh, it gives you the function.
Where the change of sign of what?
The F, well, like concavity.
The concavity is changing, that's true. F prime would have to change, if F is changing concavity, then F prime changes increasing to decreasing, or the reverse, F double prime? Positive to negative or negative to positive, like a really good way to see where that
Because you don't
happens.
have the threshold. What'd you eat?
Basic.
Not point of concavity.
Yeah, but like, I'm just saying like, how do you know, like,
For this graph over here. Did I not give you guys the equation for this?
No.
That's why. Oh my good God. I am so.
You mean for f of x?
And for f of x.
It's right there.
it's
Oh, it's right there.
X cubed minus.
Where-
Oh, I did give it to you. Well, then why are y'all struggling so much? Alright, how about because I did not plan that part of the lesson as well as I needed to, and now all these calculus teachers are watching and they're like, wow, he sucks. And you all are like, yeah, we know.
I mean,
Alright. I'm gonna pretend I didn't hear that.
R.I.P. to your grade.
Alright. Alright, shut up. If f has a point of inflection, here are the things that you know. We know, what's one thing that we know?
F of x is changing from concave up to concave down.
I'm just gonna say f of x is changing its concavity from like concave up to concave down or down to up. We also know that f prime must be making a change.
From increasing to decreasing.
Okay, increasing to decreasing, or the changes from decreasing to increasing. It could be either one. The thing that's going to be most helpful of all is that f double prime changes from positive to negative, or to change from negative to positive. It has to be one of those three. What's so nice though about this last piece is this is where you can actually use a number line test. Right, so if I know, for example, that f of x is x cubed minus 9x, let's pretend that's a 3, then that means that f prime has to be 3x squared minus 9, and f double prime has to be 6x, right? This is what I'm going to set equal to 0. Easy peasy. If 6x is equal to 0, then x is equal to 0. That number line, so handy, comes in again. At x equals 0, f double prime is equal to 0. Before x equals 0, you pick a test point.
Negative. Well,
Negative anything, right? What's the sign of f double prime?
Negative.
Negative. After 0, pick another test point. Positive, plug it in. Positive. The number line tells me everything that I need. At x equals 0, f double prime changes from negative to positive. So the conclusion? F has a point of inflection at x equals 0. So your write-up is going to look something like this. Since f double prime changes sign at x equals 0, Mr. Lanks, all right? Then f of x has a POI, and POI is legal at x equals 0.
Then F has a point of inflection at x.
POI for point of inflection, legal abbreviation.
Then T. What's T? What T came from?
Then
F.
Jesus?
Jesus has no points of inflection. Or he has all of them. It's one of the two.
Oh, I'm listening.
All right. Everybody good?
I know.
We got this under control. Tonight's homework, get all those multiple choice questions taken care of if you haven't done so already. You're going to have a short quiz as soon as you walk in. The unit test, we are like 4 days away from being done with this unit. 5 days. I know, we just started.
We just took the other one.
I know. See y'all later.